All right, well, let's begin. So welcome everyone to the research colloquium. And I'm going to literally read this because I didn't memorize it, but it is my own words, not. Okay. I'm very excited to introduce Dr. Chris Callison-Burch as our research colloquium speaker today. Chris is an associate professor of computer and information science at the University of Pennsylvania in the other city in Pennsylvania that starts with a P. He is well known in the field of natural language processing, especially for the early contributions in machine translation and crowdsourcing, which is work most everybody is aware of. His latest work relates to large language models and especially for educational applications, including a fascinating paper in AAAI that was just presented a few weeks ago, exploring if humans are able to distinguish between texts written by a human or a language model, which if you haven't read it, I think makes a very interesting read. On a personal note, I first met Chris 10 years ago, yes, I'm that old, at a summer program at Johns Hopkins, which incidentally is also where I met Bill McDowell for the first time. And then a few more years later, he was on my dissertation committee. And I also TA'd for his NLP class, at which there were 2 future duos. So 2 students from that class are now employees at Duolingo. All right, today he's here to talk about using large language models to generate course materials, which we are all looking forward to. Please join me in welcoming Chris.
Thanks. I'm super excited to be talking to you, and I didn't realize that 2 of the students in that class are now Duolingo employees. That's amazing. So as Stephen said, I'm going to talk about large language models and how I've been using them in my own courses. And I'm also going to give a little bit of a perspective from academia on like what's the reaction to the latest developments with ChatGPT and the other impacts of this technology suddenly becoming accessible to a much wider audience than it was previously. And it's clear that educators are worried about this technology. It was never on their radar before, but now it is, and now they're spooked. And I think the reason for that is pretty clear. You can play around with ChatGPT, and this is something that anyone can do now, where you can type in an essay prompt. So I tried one that I remember doing back in high school, where we asked ChatGPT to write a high school essay for me, summarizing the Lord of the Flies and including the symbolism of the conch shell. And it'll happily go through and generate a quite coherent, usually pretty accurate essay about this well-known novel that's part of the high school canon. And I think an additional worry for university professors is the kind of technologies that we currently have in place for detecting plagiarism aren't really well aligned to large language models, because I could simply press regenerate and get an equally good one. And the types of things that most people are using in their courses include technologies like Turnitin, which is great for detecting plagiarism if your model of plagiarism is that 2 students copy off each other's essays, perhaps like at different semesters, or they plagiarize something from the internet. Being able to write something from scratch that's novel each time is not in the design paradigm of these plagiarism detection software. So as a result, since December, lots of people have been in a panic. Like this is a sample of articles from a variety of pretty credible places, worrying about AI writing and whether it's possible to distinguish between human and machine-generated prose, what the implications are for making these available to students and even for scientists, and what our own governing policy should be using these as writing aids, and so on and so forth. So kind of a persistent question is this one posed here. So this is a professor who caught a student cheating using ChatGPT in mid-December or towards the end of December, which is impressive because ChatGPT, I think, was just made public a couple weeks before. So good on the student for getting ahead of everyone else. So this professor says that they could spot it because they thought it was a clean style, but recognizable. And it sounded like a smart 12th grader. And the professor said something that I thought was interesting, like it's got a particular odd wording that wasn't exactly wrong, just peculiar. And then went on to say like, well, if I were teaching someone to write an essay, this is how I would tell them to do it, meaning pretty formulaic before they figured out their own style. So this professor is kind of building a mental model of what the text generated by ChatGPT looks like. So one question that we're addressing in my research group that I think is related to this broader topic of large language models in education is, can people reliably detect generated text? So as Stephen mentioned, we just had a paper presented at AAAI by my PhD student, Liam Dugan, and my former PhD student, Daphne Ippolito, who graduated a couple months ago, is currently working as a research scientist at Google Brain before she'll be starting at Carnegie Mellon University as an assistant professor at LTI. So she'll be a neighbor. You should definitely like rope her in. She's amazing, really, really fun to work with. So Liam and Daphne led this effort on trying to do a set of experiments to understand to what extent it's possible for humans to be able to spot machine-generated text. And in part, we were inspired by this website called Which Face is Real. So if you haven't tried it before, I totally recommend it. It's here's an example. So it presents you with a pair of images, one of which is an actual photograph of a real person. The other one is computer-generated imagery. And then your job is to pick out which face belongs to the real person. Anyone want to hazard a guess on which face is real here, left or right? Feel free to type in the chat. Stephen, you're saying right?
Left.
Left, yeah. We got a little bit of a split. I think consensus is left, and that's correct. So this is the real face, and we can play again. So we'll do another round. Type in your answer into the chat. Who's real, left or right? Right. Yep. All right, you guys are pros. So this one is the correct answer. And then we'll do one more round. Okay, any guesses? Left is real or right is real? Left. Okay, you get a little bit of a split opinion, but left is in fact the real one. And so how do I know? Well, I've trained myself to be able to spot these things, right? So that's one of the advantages of this website, is it gives you a little bit of exposure to them, and it tells you what the correct answer is. So there are different tells that you can look for. So one is hairline. So this person has like very coherent little filaments. This person's hairline right here, you kind of see gets a bit wacky at the edges. The other is outside of the frame. The computer generated portraits here have nothing or something that's incoherent. Whereas here, it's like quite a coherent picture of this kid's parent. And so that's a good tell. So those are some hints. So if we play again, then we should be able to tell that this one is the real one, because like you see all the filaments of his hair are quite coherent. This one's fake, like her filaments are a little harder to tell. And also like her earrings are wacky and out of sync with each other, and the background is misaligned, etc. So this one's the real one. Right, so we said, well, let's go ahead and build our own version of this. So we have a similar kind of website called Real or Fake Text, ROFT.io, which allows people to play a game. So I just wanted to shout out Games with a Purpose are amazing. I love your founders' work. It's really great stuff. So we can try this out. So the name of the game here is we're going to present people with a series of sentences forming a story. The first one is always going to be human written, and at some point we're going to swap out to machine written. So I'll pick a category here called, so we have lots of different categories, so we can analyze the results by genre. We'll do recipes because I'm best at this one. So how to make this. So this is the human written prompt. This first one is guaranteed to be human written. So we're talking about a German romaine salad with some kind of vinaigrette. Okay. And so we says for the vinaigrette. So then we have to predict, is this a logical next thing to include? So we'll say human written so far, spoon the mustard into the medium bowl. Seems reasonable. So we'll say human, whisk half the oil and vinegar until blended. Yeah, I'm going to say that's human. Add the remaining oil and vinegar, whisk it until blended, blah, blah, blah. Whisk in water. Okay. I'm suspicious of this one, but I'm not confident. So I'm going to just go and say everything was human written. Okay, and I was wrong at the border. So the idea is we're going to have people go through and do this game. And then when they hit one that they think is incorrect, so here I've got another recipe. It's making a fennel salad. It's asking us to chop things up and then fit the food processor with the thinnest slicing blade and then scrape down the sides of the bowl and process again. So we know that this is, or this, when I'm playing, I would say this is probably machine generated because it's asking me to scrape the bowl before I've blended anything, or before I've actually used the food processor, before I've done anything. So there's not even any food in the bowl of the food processor yet. So that to me is a logical error. So I can identify, okay, there's the boundary. And so when people make their guess to say this is the start of the machine generation, the closer they are to the boundary, the more points they get. So if you hit it right at the boundary, you get 5 points. If you hit it lower down, you get 4, 3, 2, 1, etc. So that's the setup for our game. And then we did a study with students from my class. So we had 200 students participate. These are all students from my artificial intelligence class here at Penn. And we had 20,000 annotations, which I think makes it among the largest study to date on humans' ability to detect. And if you're interested in checking out the data, it's all on GitHub. So a couple of questions. Can humans detect generated text? Well, on average, they're actually not that great, right? So only about a quarter of the time did people guess the exact boundary where we swapped from human written to machine written. It's still better than chance, but not great. They could guess on the correct side of the boundary about 75% of the time, but not awesome. So this is the distribution over average player score. So what we are interested in is this range here, which represents our best players, the players who scored the highest. So among all the players, you see, their average of hitting that perfect boundary correctly, they only do it about 20% of the time, but our best players could do it about 75% of the time. And so they had like really impressive abilities to do this. So this, I think, is good and hopeful. So the question is, could we make all players more like the best players? So we tried to see, we ran an experiment to say, could we train the players to detect the text? So we split our players into 2 different groups. One is the control group. They're just part of the student population in our artificial intelligence class. We didn't give them any guidance. We didn't offer them up some documentation on how we recommend identifying it. And they got a fixed amount of extra credit. The other one was a group that we're trying to study. So we're saying from the same population of smart computer science students at a Pennsylvania university, let's give them extra credit. But now let's incentivize them to get better. So we'll give them extra credit proportional to how many points they score. And we'll give them a little bit of training. We'll give them a document to tell them what to look for. So here's the kind of snippet of a document that we had that gave them explicit instructions on signs of machine-generated text, which were true of the models that we were looking at the time, or indicative of the models that we were looking at the time. So they had this, they could kind of study up. And then we found that over time, this group got better. So they could learn to detect machine-generated text. So from their first round of playing the game to their 100th round of the game, on average, they did get better. So that's good news. I think instructors should be heartened. They could learn to detect machine-generated text. We had a bunch of other interesting findings. I'll just kind of give you the things that I think are the highlights, and the paper is filled with interesting results, like tons and tons of results in that AAAI paper. Another thing that we did is, as people guessed this is machine generated, we asked them to categorize their rationale why they thought it was computer generated. So we had error types like grammatical, fluency, repetitions, and so on. And then we had like things that are the substance of the text rather than the form of the text. And interestingly, these kinds of common sense errors were much better indicator of people being able to pick out the machine generated text versus not. And you could take a look at these distribution of these errors, and they're not uniform across genres. So I'm much better about judging the recipes, I think in part because a large fraction of the time they're making errors about how the world works. You know, if you have a good mental model of like how to cook something, then you understand the order of the steps, and you have like common sense reasoning to understand that if I put something into the oven, it better be preheated before I put it in, that sort of thing. And that's different of other genres. So in short stories, you know, they could be fiction, so there aren't as many constraints that you would find in this kind of procedural text. As a result, the average score of players on these different genres was a bit different. So fiction stories were the hardest, meaning overall people's scores were the lowest, and recipes were the easiest. This baseline is just how well do people identify a change at all? So we said, here's one human written story. Now we're going to randomly switch to a different human written story. So it's not even like detecting the boundary between human written and machine written. It's really just being able to spot where we swap out one writer for another. Okay, so common sense reasoning currently is a tell for large language models. I think the arrows are going to keep changing over time, so we'll probably have to understand how they change, and this won't be a single indicator that educators could use to spot machine-generated text. The other thing that may cause us to be a little bit more worried is that bigger models are harder to detect, as you might imagine. So much of our study was focused on GPT-2 because we started it prior to GPT-3 being released or publicly available. And so even if you just go from the base GPT-2 model to the XL model, then you see a big drop in humans' ability to do it. If you go further to Da Vinci, you find an even further drop. So basically, as these models get bigger, there appears to be a trend, as you might imagine, that they're getting harder and harder for people to spot, increasingly human-like. Another really interesting thing is we, in addition to varying the underlying models that we were showing to people, we also varied the decoding strategies. So there's a bunch of different decoding strategies you can use when you're generating text with a large language model. I'm simplifying here to just show two. One is like argmax, right? Given some prefix sequence like a hippopotamus ate my, you've got a distribution over all the words in the vocabulary on what should come next according to the model. One decoding strategy is just pick the most likely word. Another decoding strategy is take from the entire distribution sample randomly in proportion to the probability assignment, and then generate that randomly selected token. So we can see that if we use that argmax strategy, it's actually harder for people to detect than if we sample from the full distribution. So here I've got 3 different bars where I'm varying from how much of the distribution you're allowed to sample. 0% means like always take the top most probable token. 1.0 means I sample from the entire distribution. Interestingly, as we sample from more of the distribution, people get better at spotting the generated text. Probably because it like will occasionally produce weird words, right? Like I think the professor who spotted the chat GPT that the student submitted spotted some weird word choices. Interestingly, in earlier work that Daphne did, she looked at a trade-off in humans' abilities to spot generated text versus machines' abilities to spot generated text. So if we train a classifier, we fine-tune BERT to try to discriminate between machine-generated and human-generated, it's complementary. Like its strengths are the exact opposite of that spectrum. So when we're sampling from the full distribution, humans are great. They can say, that's a weird word choice. It must be generated, but our automatic classifier fails. Our automatic classifier is great if we're sampling just from the top of the distribution. If I only take the most probable word from each context, yeah, weird word choices are tortured phrases or just weird, like unexpected words. So I think I got a hidden slide, or ooh, do I have a hidden slide with an example? If you ask me to show some examples, I can show them at the end. I'll show an example of what I mean. But imagine for the automatic classifier, we are only sampling from the top 5 most probable words. We could essentially, our classifier could memorize that context. We could say, for this context, here's the 5 words that are going to appear after it. And then for sliding window of contexts, like if you see the 5 most probable words each time, bam, it's almost certainly machine generated. So there's this like spectrum of decoding strategy trade-offs between the argmax, where you have less diverse text, but as a result, there's fewer weird tortured phrases or fewer semantic errors, and you're more likely to fool humans, but much less likely to fool automatic classifiers. And when we're sampling from the full distribution, you get more diverse text, perhaps with more semantic errors. People can spot it, but automatic classifiers can't. So totally interesting complementary abilities there. So from these pieces of work, the main takeaways, the super high level takeaways are, 1, good news. You can train yourself to detect machine generated text, just like you could for the computer generated faces. 2, if as we're getting ourselves prepared, like I'm fully optimistic that educational technology companies like Turnitin can implement pretty reasonably automatic classifiers, at least to spot known models, right? Like they'll be able to spot ChatGPT, no problem. And then models are getting better, but they still make some errors that allow us to spot them. Okay, so I guess after that, should we still be worried as educators, right? Like, and I am a technology optimist, so I would say no, and I would say the reactions to ChatGPT may be like the reactions to all these other technologies that we've encountered through time, right? So people worry that using a calculator would damage students' abilities to do math and they should stick with slide rules, or that using a computer in a classroom would replace teachers and like doom us to literacy disappearing within 10 years. Spell checkers would make us terrible spellers. I don't know, I've always been a terrible speller, so hard to tell. And we should say no to Wikipedia and be warned about the dangers of flip phones and iPods. So I'm feeling like there's a worry that students are going to be lazy and use these in a classroom. That's fair, but we should also think about like, how can we be lazy? how can we use them in the classroom? So I've been thinking about this for myself and experimenting with a variety of different ways of trying to build better classroom experiences for myself and for my students with these tools. And I've been doing it for a few years. And so I teach the Intro to Artificial Intelligence class at Penn, which has grown in popularity alongside with the popularity of the field. So I would love to think it's all because I'm an amazingly engaging lecturer who's really charismatic. No, not, it's just AI is awesome. So my class has kind of grown to like over 500 students per semester when I teach it in the fall. And so I always say, oh, I got all these students, what can I do to scale myself up, essentially? Like, what are the pieces of my class that I can automate? And a lot of it is stuff that way predates the usefulness of large language models. It's things like building auto-gradable assignments, these sorts of things. But one project that I aimed to tackle was I sucked at writing quizzes. I was really bad at writing quizzes because I could never strike the right balance between wanting to make a quiz that forced students to do the reading. Like I want a forcing function to encourage people to do the reading and get some credit for having done it. But then how do I make a quiz question that isn't trivial, meaning I can open up my Kindle textbook and press Command F, find a keyword from the question and find the answer, or so convoluted as to be impossibly difficult to understand. So it was a goal for me for one semester to say, how can I write better quizzes? So that led to the kind of first piece of work that we did here, which was trying to use large language models to generate quiz questions for my class. So once again, we had my PhD student, Liam. We had Eleni Miltasaki, who's a senior researcher here who had an educational technology company herself and who's now at NSF on rotation at the NSF as a program manager. Yash and Aitan are two undergrads who have got inspired by this and started their own educational startup, and then a bunch of awesome undergrads. So we looked at the question of like, yeah, can we make some questions for Chris? So we took our textbook, we extracted the text automatically and sent it off to a question generation module to propose a bunch of question answer pairs. And then I had a team of 40 TAs. So in theory, I can have them all go through all of the questions and pick the best ones. So we used a really nice Hugging Face model based on T5 that was built by Suruj Patel. So T5 is a multitask learner. So Suraj fine-tuned T5 or continued training to T5 on a bunch of different tasks. So one is like regular question answering tasks. So given some short passage of text and an associated question, generate the answer. The other was given a span in some text, generate a question. So if you give it this with this highlighted span, then generate a coherent question for it. And then finally, just given a whole bit of text, pull out a span within it that's a likely answer. So it's doing this multitask learning on a bunch of different tasks. So we used this as our question generator. One nice thing is you don't have to already have an answer in mind. You can generate question answer pairs just from any kind of text. So we did a round of experiments. The first one was if I just send the unmodified textbook text through this, how often are the question answer pairs generated ones that our teaching staff would directly use as a quiz question? So only about a third was that case. And then we broke it down. We broke down the error types into how often were the question answer pairs grammatical. We're actually doing quite well with there. How often is the answer correct? But then we had these places where it was going wrong. So one was interpretability. Does this question make sense out of context? So here's an example of one that doesn't. So this is a question answer pair produced by the model. What seems to matter more than its frequency? What does it refer to here? Whether a word occurs or not. And here's an example of one that's not relevant. So, oh, sorry, I edited this wrong. Who named the minimum edit distance algorithm? Fine, probably a correct answer, but not particularly something I would want to test a student on. That feels like irrelevant to the understanding of the minimum edit distance algorithm. Okay, so an approach that we took was to say, instead of just taking the raw textbook text, let's first pass it through an automatic summarization system. We're going to then take the output of that automatic summarization system and then pass that to the question generation module, and then let the TAs pick out the best questions. Right, so for this version, we again use T5 to do automatic summarization. This is something that is getting better and better. Like, this is when I first started playing with GPT a couple of years back. This is one of the things that started causing me a career existential crisis, is like, I feel like summarization is maybe not solved, but it's way, way, way easier than it was. So even just the difference in 2 years since switching from T5 to GPT-3 is impressive. So this is extractive summarization. I feel like we've got new experiments with GPT that do abstractive. It's really, really good. Okay. And so the takeaway is this approach of distilling the original textbook text down into a summary tends to improve interpretability and relevance. So overall, we get better, but maybe we think that our automatic summarizer could introduce errors. So here's an example of the Jurafsky and Martin textbook where they're talking about regular expressions. They're saying, and our summarizer says the disjunction operator, also called the pipe symbol, and then we pick out matches either the string cat or the string dog. And it's actually that pattern that matches it, not just the pipe symbol. So that's an error. And so what if, so in this original set of experiments, we said, well, let's replace the automatic summary with a bunch of human written summaries instead. And what's the headroom that we have to get better? And in fact, if we had a high quality human summaries, we got way, way better, right? So we bumped up from only a third of the questions being directly selectable as quiz questions to 50% with the automatic T5 summarizer, all the way to 80% with human written summaries. So lots of promise there. So because of my background in crowdsourcing, I thought, hey, what would make my class more like a superpower and less like a burden? If I start thinking about all of the students in it as potential participants in my research. So I've had a lot of success of thinking of different ways to get students involved. I'll often offer extra credit for them to participate in my PhD students' research. And then the PhD students write little blog posts to explain what they learned from the students. And it feels a little bit like Luis Fanon's cleverness with getting people involved. So giving incentives to get people involved. Here, I'm giving incentives for students to write summaries by saying, hey, you know how I used to let you use 1 page of handwritten notes on the midterm? How about I change that up so you can kind of write unlimited notes? The only constraint is you have to put them into this Colab notebook that I'm giving you. I gave them a Colab notebook, and I broke it down into each of the textbook chapters that was part of the required reading. I let them summarize my own lectures. I let them define important concepts from the textbook. I even this year started having them describe figures and pseudocode in the textbook. So now I've got a bunch of student written descriptions of each of the figures in the textbook. So I also don't mandate that they let me use their notes. So I say, if you're willing to let us use these for research purposes, please say yes here, and then decide whether you want to be anonymous or get credit. So and this will not affect your grade. And so almost 400 students volunteered their cheat sheets for the exams. And so now we have hundreds and hundreds of summaries written for these 2 textbooks. So this is interesting because we said, oh, the human written summaries were really quite good. They were better than the automatically generated summaries when we wanted to apply them to the task of question answer generation. But interestingly, those original summaries were written by the research assistants on the project who were doing it quite conscientiously, carefully, not under particular got to prepare for the exam time constraints like these students were. So there's a wide variety of styles of the summary. Some students wrote full paragraphs with complete sentences. Some students jotted down a set of bullet points, things like that. So we thought we analyzed is this kind of a summary as good as the summary, or what's the range of quality of human summaries for the downstream task of flashcard generation. And we also looked into, could we make the ones that we suspected were going to be worse and look more like the ones that were going to be better. So we did this process, or now we switched from T5 to GPT-3 because I got early access to it and was as mind boggled as everyone is about ChatGPT. And for a brief period that is still ongoing, my answer to every PhD student question is, have you tried GPT-3 yet? Eventually I'll get out of that mode, but still there right now. So anyway, a general recipe that we use is start out with a zero-shot prompt to try to do the task we want, look at a bunch of its outputs, edit some of them, construct some few-shot prompts where we have several examples that we like of inputs and outputs, and then generate a bunch that we edit, and then we've got enough to do fine-tuning. So basically we say, okay, here's a zero-shot output for, take this bullet point outline and turn it into a paragraph. I guess, what did we say? We said, here's an outline, please expand it into full sentences and paragraphs. We give an outline, and then the GPT-3 outputs a nice paragraph-sized full sentence summary. We then do that a bunch of times, go through few-shot learning, then we gather and edit about 100 input-output pairs, showing it what we want, and then we can fine-tune the model. And we use that same kind of bootstrapping process for question-answer pair generation. So also replacing the nicely written question-answer T5 model from Hugging Face with our own fine-tuned GPT. So take a bunch of summaries, generate question answer pairs, select the ones that we like, discard the redundant ones or whatever, save a bunch of data, generate. Okay, and then we have this idea of what's the best input to our question generator. So we replicated the previous ACL paper, where we took the original textbook text. We also did the automatic summary. We now had two kind of indicative sets of summaries, the full paragraph, full sentence ones that we thought were higher quality, and the ones that are the sketchy bullet point ones. And then we have this extra step of saying, okay, let's take the bullet point ones and enhance it by rewriting it automatically. And then for each of those, we have a set of question answer pairs. We had, again, the power of extra credit sourcing. We had 9,000 question answer pairs adjudicated by students taking the class, asking for this kind of a flashcard, would you directly use it? And then if not, is it because it's ungrammatical or it doesn't make sense out of context? So we replicated those kinds of questions. So we also compared with T5, GPT is better, larger models, awesome, great. I'm kind of going to omit that here. We have 9,000 human judgments about the question answer pairs, redundantly annotated, et cetera. So, okay, so back to the original questions. What fraction of these would we do depending on the source? So this column is what fraction of these would the students think are directly usable as flashcards? If you take the text from the original text from the textbook, now they're improved. So instead of being a third, it's now 50%, but still not great. Similarly, if you take the kind of bullet point sketches from student written summaries, it's about 50%. The GPT generated summaries are also pretty good. So that bumps you up to 2/3 of the questions being acceptable as is, but there's still a bit of room. So if you have the higher quality human summaries, you can still do better. If you transform the lower quality bullet point summaries to look more like the higher quality ones, then you kind of equalize that difference. So now 70% of these instead of 50% of these are good. Okay, same with all, similar trend with all the other numbers. Okay, so the takeaway from this study, which is currently under submission, is something I don't know that this counts as science, but it's practical for people doing it on their own, is like GPT-3 summaries are better than the summaries we were generating with T5. Again, that kind of goes to like mind being blown by how good these systems are. Like really summarization is quite good. But the human summaries are still better if your downstream task is you want to generate these flashcards. And then there's interesting room for addressing the variety of quality in human written summaries, or the variety of styles. Okay, and then I'm going to give you a little quick preview of this cool ed tech company that's come out of a couple of the students in the group. So they've got a company called Martian. So you can check out withmartian.com, learn.withmartian.com. So it's a platform designed for me. Thank you, students. I'm not a shareholder. I don't have any equity, but I'm their target audience. So it lets us create quizzes more effectively. And they claim with 5 minutes of my time, they can link our courses through Canvas to their platform, and we'll use their transcripts, our textbooks, and our assignments to generate some questions. And they've got a really nice like interface for question generation that uses the same kind of techniques that we just described. And we actually used this, and it'll generate flashcards for students to use. So we thought, I was sick of like using these crappy quizzes, so I replaced it with these Martian flashcards, and again did a controlled study, which is fine, but it found that in fact a genuine improvement. Yeah, so the fine, like, does it? How do you make it fair so that one group of students, that's the control group, isn't penalized? Well, the answer is you just give extra credit. You give so much extra credit, and of course that almost everyone gets an A or an A plus. So that's how I reconcile my my experimentation on my students. So anyway, it seemed to work well, and there's neat aspects that they have. So one of the co-founders, Eitan, was a world memory champion, and he like uses this technique called spaced repetition, which is also built into this platform for showing when to show cards. So the idea is you've got a memory decay function. So you rehearse something, you keep it in your memory, and then over time it decays and you forget it. So you can kind of optimize your spacing out, and the decay gets like more gradual, like you retain it for longer over time. And so you can optimize how often you do it, how often you and when you review. Okay, so there's my sales pitch. Cool company. You guys should be friends. A couple of other just quick little highlights, like what else could I do with these things? I love them. Can I do it for everything? So one experiment that I'm doing now is I ran a senior design team who looked at using large language models to automatically summarize the transcripts of my lecture videos. And it's kind of like we break it up into chunks. We use the raw transcript produced by first like AWS, and now I'm using Whisper, which is really amazing. If you haven't tried it, definitely worth checking out. So this is examples of the inputs and outputs. So if I'm giving a live lecture, I talk in a way that you as a listener will accommodate, but that's really, really hard to read after the fact. So there's lots of filled pauses. I start every sentence with so, or every paragraph with so. I use a lot of ums and uhs. I actually like have this neat program called Descript app that will automatically delete all the filled pauses. So I edit my videos, and I think I lose about 10 minutes of time just on uhs and ums and pauses. Anyway, so a transcript will have things like, so if we're just talking about, and then a repetition, we're just talking about input sequences for a problem with dimensionality, then let's imagine we've got an input sequence of like 10, and like we've got, okay, let's imagine we've got a vocabulary size, blah, 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 right? So this is not appropriate for students to consume. But if you summarize that, you get a really nice, coherent, distilled thought of what I was trying to say. If we have a vocabulary size of 100,000 and an input sequence of 10, there are 100,000 to the power of 10 different possible sequences. This is too high to estimate from data. I feel like the quality is like really at the level that I could make a draft set of lecture notes out of just running my transcripts through this kind of summarization. Did a large scale human study. We designed a little interface, ran an in-lab thing with 100 students. Modest gain in learning. I'm not really statistically significant, but I'm still pretty optimistic that this is going to be an interesting tool to use. Another fun thing that we're trying is, in addition to summarizing the text and generating questions and flashcards and things, it would be nice to kind of map out like what are the key concepts in the text, and maybe even in conjunction with the automatic lecture summarization, being able to like highlight the key concepts and define them. So we took all of those textbook sections that the students carefully summarized. We got all the concepts associated with them. Now we have a set of labeled data where we can say, here's the original textbook text. We want to fine tune a model to predict what terms would be bolded in it, essentially. And so now we can run it through some other texts, non-computer science. We can say, here's a textbook about biology, about the Cambrian explosion. In the original text, it's Cambrian explosion is highlighted. So we predict Cambrian explosion is the right phrase that might be a good concept. The other interesting thing is we're also trying to define it. So we say, not only generate that it is a Cambrian explosion that's core concept of this passage, but we want to say the Cambrian explosion is a rapid evolution of new animal phyla and animal diversity in Earth's history, occurring approximately 500 million years ago. Okay. The other cool thing is you can get a list of concepts. So this is the one that was actually bolded in the text, but we can have it continue to generate concepts, and it'll pick out things like phyla. This is not directly defined in this text, but because we're using this as input, saying, given this context, meaning a biology textbook and the term phyla, generate a definition for me. And then top predator is mentioned in the text here, but not defined, but it comes up with a perfectly reasonable definition. Okay, so these are the kind of things that I'm thinking about at the moment. They're things that I think are super exciting as a possibility for integrating these large language models into course materials. I feel like it's really exciting that everyone's getting exposure to this kind of technology through ChatGPT. And I kind of want to give my colleagues a set of ways of thinking about it in a positive light, because I feel like too many of them are just terrified that this is going to spell, cause a massive cheating wave or spell the end of their careers or whatever. But I think that that's unlikely, And so I think exciting times ahead, and I look forward to what we can come up with using these in the classroom. All right. Thank you for your time. I really appreciate it.
All right, thanks a lot, Chris. This was great. We have about 8 minutes, so this is perfect timing for questions. So if anyone has any questions, either in person or can you see the chat, or should I read it to you?
I can see it. So can we set up a Martian class basically just for ourselves? No, you should definitely request a demo. If you're excited by it, they would be delighted to show it off to you. And if you want an introduction directly, feel free to, anyone who wants to chat or follow up about any of this stuff, you're totally welcome to drop me a line. My email address is in the chat here, just my initial ccb@upenn.edu. Oh, and I should say I'm on sabbatical this semester, so like I have free time. I'm not teaching 500 students all at once, so there's a much better chance that you'll get a reply in a timely fashion from me than normal. Oh, and I should also say I'm thankful for my sabbatical host, which is AI2 in Seattle. Like I'm really having a lot of fun, and I'm trying to figure out like what I want to be when I grow up. So.
Any other questions?
I have one.
I'm curious. Oh, sorry, James, do you want to go?
It's okay. So I was just really quickly curious if you were going to use this for grading, creating grading rubrics. Rubrics in particular, I think it's a more incremental step than full-on grading.
Yeah, I think that's a great area to explore. So by virtue of having scaled my classes up already before the like amazing capabilities that got introduced fairly recently by large language models, I've done a lot of automation on the grading end already, right? So we use GradeScope. We have tons of test cases. I'm fortunate enough to work at a university where students are very driven to the point where I never have to worry about motivating students to do things. I really just have to get them to chill out, like, and not worry about what their grade is like. And so my strategy has been just open all my test cases. So basically for all my homeworks, it's like WYSIWYG with the auto grader, like that's your score, that's what you're getting on the homework. And then they can, work until they get 100%. So, and, but that like is only for a class of homework assignments where we've got like programming assignments where we hand built test cases. And then my exams are super boring, right? Like they're typically multiple choice fill in the blank because I don't want to spend, whatever. I already said I'm a lazy professor. I don't want to spend all my time reading 500 student essays and grading them there. And I think even like when Stephen was the TA for my NLP class, we did a lot of essays for that class. And I'm rejiggering that class so I can offer it for a Penn Engineering online degree. And I'm trying to figure out what's the appropriate balance because I love it. I love to have students like be thoughtful and write essays or design their own projects and figuring out how to scale it up. So if you have any thoughts about like how to use language models to make that more feasible, I would love to chat more or love to hear your thoughts. But yeah, and then I've got, I guess, one of my friends who's a writing instructor was like really jumping in with 2 feet to ChatGPT and thinking about like, how could we just say, let's use this as a tool for writing criticism and basically like the robot is a peer review and you think about how to design prompts and stuff like that. And he said he even like asked ChatGPT like, write a Canvas module for me for this topic. And it like gave a pretty coherent set of suggestions, like, because of the lack of truthfulness and the propensity to hallucinate, it gave some really good suggestions on papers that he should include in his curriculum on his syllabus that do not exist, but were great suggestions if they did.
Yeah, I have a lot of infeasible ideas for improving the feasibility. So,
That's research, right?
Yeah, exactly. We can maybe dig into it offline.
Yeah, that'd be great. And no, I should mention that I've got some calendar time booked for meetings with you. So I think Stephen probably communicated it already, but I've got 1:30 to 3:30 Eastern blocked off for meetings and love to chat with anyone. And yeah.
Better has a question.
I have a more legitimate question I'll save for the meeting time later. I guess the other question I'm just curious to get your thoughts on. So you present all these examples of all these times where people have freaked out about a new technology ruining our ability to do something. Whenever I see examples like that, I always wonder, it's been a pretty unique 170 years of human history. Maybe all those naysayers were right. We don't spell as well, we can't do arithmetic in our head, and maybe that's okay. I mean, we have more time to do other things and gain other skills. So I guess I'm curious, from that perspective, maybe this will replace how a lot of students sort of approach at least the first drafting of their essays or whatever else there's do. But are there other skills that you see that we're freeing up our time for? So again, this is not the technical question, but that you do positive, even if it's being used in the worst case.
Yeah, I mean, I think it's actually a super interesting core question. So I went to a teaching, Penn has a Center for Teaching and Learning aimed at faculty improving, self-improving. And so I went to one that was I think the most ever popular one for a long time, which was what the fuck do we do about ChatGPT? And a lot of the discussion went in that direction in really interesting ways, right? Getting people to reflect about what is the core set of skills that we want students to have? How can we instill in them those core competencies, but then allow them to build off of those using automation? And I think it's a super interesting question, and it feels analogous to what extent you use calculators in math class, and or I think for all of us as people who write software, to what extent you should have the foundations of software design before you start using Copilot or Codex or whatever, right? And I feel those are questions that we can now think about in lots of different disciplines, right? Composition and writing, and I think is core among them. And I feel having a vocabulary that students know on what are the elements of style, what are the core elements of argumentation, all these sorts of things, and then being able to articulate them to the system, understanding the limitations of the current systems and understanding that they'll change over time. I feel there's lots of interesting things that we could do, but it's early times. I feel we won't have a good sense of A, what are best practices, or B, will this cause skills to atrophy for many years?
Thank you. That is time. Many of us will be meeting with Chris later, so we have lots more questions for you, but thanks again for coming, giving a talk to us, and thank you one more time.
Our pleasure. Thanks so much for hosting me, and I'm looking forward to chatting with you later. Bye, everyone.